Assalamualaikum and welcome to BFC 15003 Calculus. Okay, so in this video, we will learn about the application of differentiation. Okay, so basically there are many application of differentiation, which is one of it is rate of change. Okay, so let's see some introduction. Okay, so if y is a function of x, then dy dx is the rate of change of y with respect to x. In application, rate of change must be accompanied by the appropriate units. So in general, the units for a rate of change of y with respect to x are obtained by dividing the units of y by the unit of x. Okay, so let's see, for example, okay, if we have y, okay, for example, this one is the first example, y represent, okay, it represent a displacement. Okay, for example, it represent the displacement in meter. Okay, so in meter. And we have t that represent, okay, so represent time in seconds. Okay, in seconds. So therefore, okay, therefore dy dt, okay, we can say that dy dt, okay, is the rate, okay, is the rate of change in y with respect to time t with unit, okay, with unit of meter per second. Okay, meter per second, which is m meter over second. Okay, so let's see some example of a question that related to the rate of change. Okay, so let's see the first question. At time t, okay, so the volume of water in a leaking tank is volume centimeter cube. Okay, V centimeter cube, where V, it is equal to 100 minus 3t minus t squared. So find the rate of water flow from the tank at t equal to 6 seconds. Right. So let's see how can we solve this one. So given, we are given V equal to 100 minus 3t minus t squared. Okay, so therefore, the rate of flow is given dv over dt. Okay, which we just differentiate. When we differentiate v, we get negative 3 minus 2t. Okay, and then the question asks find the rate of water flow from the tank at t equal to 6 seconds. So therefore, we just substitute the t value with 6. Okay, so now dv dt, it is equal to negative 3 minus 2 times 6, and we will get negative 15. Okay, so thus at t equal to 6 seconds, the value of dv dt is negative 15 centimeter cube per second. Okay, so this one, this is the answer. Right. Okay, so the negative value indicates that the water is flowing out from the tank at the rate of 15 centimeter per second. Okay, so while the negative sign of dv dt indicate that the volume of tank, the volume of water in the tank is decreasing. Right. So let's move to the second example. Okay. So the question, the length of each side of a cube being heated is increasing at the constant rate of 0.002 centimeter per second. Okay, so the first question state the total surface area of the cube A in terms of x, the length of each side, and find dA over dx. Okay, so now the first thing is we need to find the total surface area. Okay, the total surface area. So we know that, okay, we know that area of one surface of this cube, okay, is equal to x times x, isn't it? Okay, because the length is x. Okay, we don't know the what is the length. Okay, we just make it x times x. Now we get the surface area of one surface. So we just simply write x squared. Okay, so now the question asks state the total surface area of the cube. Okay, since the cube has 6 surfaces, so therefore the total area will be 6 times x squared. Okay, and then the question asks find dA over dx. Okay, very simple. So dA over dx is equal to 12x. Okay, right? So this is the answer. Okay, let's move to the second question. Okay, so the second question state that if the initial length of the side is 10 cm. Okay, this one is the initial length. Okay, after the cube has been heated for 50 seconds, calculate the length of the side. Okay, so from question here, it already stated that the length of each side of a cube being heated is increasing at a constant rate of 0.002 cm per second. So this one, it is dx over dt. Okay, dx over dt. So now we want to calculate the length, okay, the length of the side, okay, the length of the side after being heated for 50 seconds. Okay, let's see how can we calculate this one. Okay, so given we already have dx over dt, it is equal to 0.002. Okay, so we know that dx over dt, it is equal to the change in x and also change in t. Okay, because we want to know the length of the cube after 50 seconds being heated, so now change in x is equal to x minus the initial length, which is already being stated here. The initial length is 10 cm. So x minus 10 divided by change in time. Here the question already stated that the cube has been heated for 50 seconds. So the change in time is 50 seconds. Okay, so we already know dx over dt is 0.002. So we just substitute 0.002. Okay, so now we can get the value of x, okay, which is equal to 10.1 centimeter. Okay, 10.1 centimeter. So it shows that after 50 seconds, the length of each side of the cube is 10.1 centimeter. Okay, so let's see the third example, the third question. Calculate the rate of increase in the surface area at that time. So the question asks, okay, to find what is the rate of increase in the surface area? That means dA over dt, right? So the question asks to find dA over dt. Okay, so let's move here. Okay, so the rate of change of surface area. Okay, how can we get here? dA over dt, it is equal to dA over dx times dx over dt. Okay, so now we already get, okay, from the first question, we already found dA over dx, which is equal to 12x. Okay, 12x. And then we already get the value of dx over dt. Okay, from the question, we know that dx over dt is 0.002. Okay, so now we know that dA over dt, it is equal to 0.024x. Okay, so the question asks, calculate the rate of increase of the surface area at that time. That means after the cube has been heated for 50 seconds. So we know that the length of the cube at 50 seconds is equal to 10.1 centimeter. So now we just substitute, okay? So when we substitute the value of x, we will get dA over dt is equal to 0.024 times 10.1. And finally, we will get 0.2424. Okay, 2424 centimeter square per cm. Okay, so thus after 50 seconds, the increasing rate of the surface area is 0.2424 centimeter square per second. Okay, so we will stop here and we will continue the next subtopic in another video.